course on sequence and series. In this lecture, we are going to see about logarithmic test and Gauss test for checking the convergence of series. Right? Here, what does this logarithmic test says? That we will see first. Here, if you see, we are given a positive term series summation un, which means what? Un is a positive quantity. Okay? And when this case, we evaluate this limit, that is limit n approaches infinity and n times of log un upon un plus 1, we evaluate that limit, and when the limit is L, we take that limit to be L. When that L is bigger than 1, the series converges. Okay? And when L is smaller than 1, the series diverges. As usual, when L is 1, the test fails. Okay, when do we make use of this test? That is a question mark, right? So, supposing we are given with some random series. Of course, we will try first one. The first thing that we will try is that we will look for comparison test. Okay? And when the series fails to give us the result using comparison test, we will come to the next sets like D'Alembert's ratio test or Cauchy's root test or any among this. Right? Even that is not giving you a proper result in the sense, then we will move to the Rabi's test that we have seen in the previous lecture. And even then, when those tests does not work, then we comes to logarithmic test. Okay? Let us see an example. Consider x plus x plus this is the series that we are considering, right? Here you may choose your x to be positive so that it stays in this category. Okay, we have something of this form. Here, what is the general term un? So when your n is 1, you have simply x. When your n is 2, you have x power 1 plus 1 upon 2. When your x is 3, you have this thing. Therefore, your x n is going to be x power 1 plus 1 upon 2 plus 1 upon 3, and it goes till 1 upon n. This is going to be our un. So, un plus 1 will be what? X power 1 plus 1 upon 2 plus 1 upon 3, and it goes till what? 1 upon n plus 1. Okay. Here, from these terms itself, we can easily see that D'Alembert's ratio test will be applicable to this, and let us find un plus 1 upon un, and this may be written as x power 1 plus 1 upon 2 until 1 upon n times of x power 1 upon n plus 1. Okay, this we may write, and upon x power 1 plus 1 upon 2, and it goes till 1 upon n. So these two terms gets cancelled, and we are left with what? X power 1 upon n plus 1. We have taken x to be some positive quantity, right? Therefore, limit n approaches infinity, un plus 1 upon un is what? When you make your n approaches infinity, what are you going to get? You will have this to be what? Anything per 0 and is going to be 1. If your x itself is infinite, okay, then that time the limit does not exist. Either you have the limit does not exist or it is 1. In both the cases, test fails. Okay. Here, I would like to remark one thing that is applicable for all the tests. Whenever the limit exists, then we will examine what is the things happening, and we see whether it is convergent or divergent or the test fails. Apart from these three cases, we have one more case. That is, whenever the limit does not exist, then also the test fails. You cannot study the convergence using that test. You will have to go for other thing. Okay. Here, since this is happening, we conclude that ratio test fails. Okay. Once the ratio test fails, then we will try by Rabi's test. For which what should we do? We will have to find out what is un upon un plus 1. This is going to be x power minus 1 upon n plus 1. Right? Hence, n times of un upon un plus 1 minus 1 is going to be what? N times of x power minus 1 upon n plus 1 minus 1. And when you make limit n approaches infinity to this, what are you going to get? You will get infinity times of 0. Since this is going to be 1 minus 1 is 0, so you will get infinity times of 0. This means what? The limit does not exist. So even here you have the category that the test fails. In these situations we will come to logarithmic test. Logarithmic test tells what? We will have to find out log of un upon un plus 1. What is going to be log of un upon un plus 1? Here you may see that it is minus 1 upon n plus 1 times of log x. Directly I have written. Okay, this may also be written as 1 upon n plus 1 times of log 1 upon x. Right? So when you take this minus 1 to the power of x, and it is x power minus 1, hence it is 1 upon x. Okay, then we will multiply n and take limit n approaches infinity. N times of log un upon un plus 1 is n times of 1 upon n plus 1 log 1 upon x. And when you make your limit n approaches infinity, here you may take n outside, so it becomes what? 1 upon 1 plus 1 upon n, n gets cancelled, and this is going to give you what? Simply log 1 upon x. Right? When you make limit, when you find the limit of this thing, you are getting log 1 upon x. Now, from the value of log 1 upon x, we are going to decide the things. That is, when log 1 upon x is bigger than 1, the series converges. Summation un converges. Right? When log 1 upon x is smaller than 1, summation un diverges. Log 1 upon x equals 1 means test fails. These are the three categories, right? Here, log 1 upon x bigger than 1 means what? 1 upon x bigger than e. When you take reciprocal, when you take reciprocal, what are you going to get? Your x must be smaller than 1 upon e. Similarly, this gives you 1 upon x smaller than e, and this tells you x bigger than 1 upon e. This is 1 upon x is e, which means x is 1 upon e. Okay, so for this series we have examined the convergence when x is smaller than 1 upon e and when x is bigger than 1 upon e, and it is still remaining to check what happens when x is 1 upon 3. That we will see using Gauss test. Gauss test tells us that if we are given with some positive term series, that is all the terms in the series are positive. If we have some series of that sort, then we find the ratio un upon un plus 1. And if the ratio can be expressed as alpha plus beta upon n plus gamma n upon p par n. This, n par p. This p may be any positive quantity. Right? And what? Here you may see these things that what is this gamma n? This is some bounded sequence. Right? And if we have expressed this un upon un plus 1 as this, and with the values of alpha and beta, we may decide whether the given series is convergent or not. When your alpha is bigger than 1, the series is convergent. When your alpha is smaller than 1, then the series is divergent. Okay? When alpha equals 1, then what happens? When your beta value bigger than 1, it is convergent. When your beta value is smaller than or equals 1, it is divergent. Okay? Here, there is no possibility of getting failed. Okay? It is going to tell you whether it is convergent or not. And The series that we have considered in the problem is summation x plus x power 1 plus 1 by 2 plus x power 1 plus 1 upon 2 plus 1 upon 3, and it goes this way. We saw that when x equals 1 upon e, the test fails. Right? Here we are going to check for the case when x equals 1 upon e. Okay? We are going to continue the same problem. Right? When x equals 1 upon e, what was our un upon un plus 1? It was x power minus 1 upon n plus 1, right? Was it so? Yes, I think. And here, when it is 1 upon e, we have this. So, this may also be written as e power 1 upon n plus 1, right? Okay. Now, we must try to express this value as in this form. Okay. We also know that e power x may be expressed as 1 upon x plus x square upon 2 factorial, x cube upon 3 factorial, and it goes this way. So when you expand it, what are you going to get? You are going to get un upon un plus 1 is 1 plus 1 upon n plus 1 plus 1 upon 2 factorial times of n plus 1 whole square plus 1 upon 3 factorial times of n plus 1 whole cube, and it goes this way. Right? And here you see we must have some alpha plus beta upon n. Okay, we have some alpha, only the constant part we have. In the denominator we must have only n, whereas we have n plus 1. How to do it? Suppose we have 1 upon n plus k, but in the denominator we must try to bring out only n. So in this case we may have take this to n outside, and it becomes 1 plus k upon n. So when you take it to the numerator, what are you going to get? You are going to get 1 plus k upon n power minus 1. So this is going to be 1 upon n times of 1 minus k upon n plus k square upon n square, and it goes this way. Okay, and squeeze this. Now do the same to un upon un plus 1. What are you going to get? 1 plus 1 upon n times of, so in the place of k we have 1. So 1 minus 1 upon n plus 1 upon n square, and it goes this way. Right? And this is going to be 1 upon 2 factorial times of, when you do the same to this, you will have what? N square you will take outside. Okay? 1 minus 1 upon n plus 1 upon n square, and it goes this way, the whole square, and it goes like this. Right? From this, let me take 1 upon n thing, and remaining you may see that what? All the terms will have minimum of n square plus 1 upon n square I will have, and the remaining things, let me denote it by gamma n. Okay, from this term, or in all those terms, let me choose this thing. Okay, now it is remaining to check whether this gamma n is bounded or not. Okay, that how are we going to check? So as of now, forget about this. Just look at these things. Here, what? Can we see it is bounded? How are we going to do it? Right? So in all those terms, you have these things, right? When you make your n approaches infinity, these things approach tends 0. Okay? And it is evident that it is bounded. And hence, what is alpha value here? Alpha is 1 here, beta is also 1. Hence, the series diverges when x is 1 upon 3. Okay, so the series, that is summation x power 1 plus 1 upon 2, and it goes till 1 upon n, converges for x smaller than 1 upon e, and diverges for x bigger than or equals 1 upon e. Thank you for watching.